Okay, we're continuing with the model problems for the 5.1 to 5.4 review in Algebra 2. And in problems 17 and 18, we're supposed to find the greatest common factor of the expression and then factor that out. So we look at the numbers in problem 17, the 15, the 10, and the 40. Pick on the smaller number, 10, and its factors in reverse order, the biggest being 10. 10 goes into 10, 10 goes into 40, but 10 does not go into 15. So then you back down and pick the next biggest factor of 10, which would be 5, and you can see that it goes into all three of them. So the greatest common factor is 5, and you pull it out in front of the parenthesis, and then you have to figure out these values by working backwards here. 5 times that value has to give 15x squared. And then you ask yourself, what do I have to multiply in the second slot to get negative 10? And so 5 times negative 2x would give negative 10x. And finally, in the third slot, 5 times that blank, we'll fill that blank in, has to give 40, so we'll fill that in with an 8. And you end up with the factored version, 5 times 3x squared minus 2x plus 8. And you fill that in the answer column. Okay, on this next one here, you'll notice that these numbers both divide by 3, and there is no bigger number that goes into them. You could try 12, but 12 doesn't go into 15. The next highest number that goes into 12 would be 6, and it doesn't go into 15. So then you go down to 3, or 4 actually, but 4 doesn't go into 15. And then 3, and sure enough, 3 goes into both of the numerical parts. Notice that there's also x's in both of them, so you have to pull an x out, and then you just go work backwards. Let me cross this out, and I'll show you the process here. You put your common factor on the outside, and then you pretend you're distributing. 3x times the first blank has to give that, and so you can see a 4x has to go there. And 3x times the back half. Well, what would we put in that blank to get a 15x? We have the x already, we need a plus 5. So the factored version is 3x times the other factor, 4x minus 4x plus 5. There's a multiplication right there, and that's what it means to factor, is to create a multiplication that wasn't there before. Okay, we're supposed to factor the next 4 problems here, and if it doesn't work, you have to write prime. All right, so the first thing you look for is a GCF. Now, there is no number that divides into 1, 13, and 48 other than 1, which is never helpful. So there's no GCF. So then we switch methods. We're going to try and do the star method here. The leading coefficient goes on the wings, and you multiply the ends. Put that in the top slot, and the negative 13 goes underneath. Now, the way this works is you have to have 2 numbers that multiply to give 48 and that add to give negative 13. So multiply to give negative 48 and add to give negative 13. And we're going to use our calculator to help us. We'll go to our y equals key and type in 48 divided by x. This is just a way of displaying the factors of 48. And then go second table settings. You want your table to start at 1. You also want it to be set on automatic mode before you go to your table. And here you see the different ways of getting 48. You can do 1 and 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. This one here with the decimal is not a factor of 48, so we'll ignore that line. Okay, we're trying to get 13, and you can see maybe that this pair, 3 and 16, is the one that we're going to try and use. So I'll put those down, 3 and 16. In order for them to add up to the correct value down here, you need to put the negative on the 16, and now you double check. Does 3 times 16 give negative 48? And 3 plus negative 16 gives negative 13. Okay, you simplify both sides, but these are already simplified. So what we have here is, when you turn this sideways here, you get 1 times x plus 3. and then 1 times x minus 16. Double check your work by foiling it. So first times first is 1x squared. That worked out just fine. We have a 3x in the middle minus a 16x on the outside, and that gives the proper value of negative 13x. And finally, 3 times negative 16 gives negative 48. Now the other way to check it, you quit to your home screen, and you put in some random number for x. Here I'm using a 1.23. There's nothing special about that number. And then I type the original expression. There's the original problem. And I compare that with what I think the answer is. And if they're equal, we should get equal amounts on our screen here, and we do, so there's our confirmation that we've got this factored correctly. Okay, here's another example. I'm trying to find a common factor, and the smallest number is 5. 5 only has one factor, other than the one that doesn't help, the number 5 itself. 5 divides by 5, but 18 doesn't divide by 5, and neither does 8. So since we've used up the only factor that would have worked, there are no GCFs, no greatest common factors. Okay, there is no greatest common factor. All right, we put the leading coefficient on the wings, multiply the ends. We need two numbers that multiply to give 40 and add to give 18. I take that back, multiply to give negative 40 and add to give 18. So using a calculator to help you with that, you go to your y equals key and put in 40 divided by x. Set up your table. Go to your table and scan the list for numbers that look like they might give 18, and the second pair here is the one we want. You could get 18 by putting a negative on the 2. Let's see if that works. They add up to 18 and they multiply to give negative 40. We're in business. Simplify this to 4 over negative 1. Go ahead and fill in the first part of your answer. And this side over here, 8 over 20 by dividing by 4 becomes 2/5. Let's double check this by just foiling it. 8x squared, that worked out. Minus 2x plus 20x, that worked out. And last times last is negative 5. Everything works. Okay, last two problems here. We're looking for a common factor. And again, there is no greatest common factor on this problem. It's pretty easy to tell. The smallest number is 2. And other than 1, the only number that does divide into 2 is 2 itself. Sorry about that. But 2 doesn't go into 15. So we don't have any common factors. All right, let's go ahead and start with the star method here. We're going to put 24 on both sides. And 24 times negative 15, let's find out how much that is. We have negative 360. And the negative 2 in the middle there. We need numbers that multiply to give negative 360 and add to give negative 2. So let's use our calculator. This one's really hard to do otherwise. 360 divided by x. Go to our table. And I want to scroll down here until I can find some that I can get a negative 2 out of. $18 and $20. There we go. 18 and 20. If we put the negative on the 20, we'll be in business. Okay, these two divide by 6, so you get 4/3. And this side divides by 4. So you get 6 over negative 5. And we're going to double check to see if this works. Our first times first should give 24x squared, and it does. Our last times last should give negative 15, and it does. You get 18x in the middle minus 20x on the ends, and that would turn out to be the right middle value. So everything worked out fine on that one. Okay, while I'm here, I'm going to comment that if you want to turn this around the other way, it doesn't change the answer. And you can see that I took the factor that was up front and put it in back. And you haven't changed the answer when you do that. Okay, here's the first one we've had that has a common factor, and this one has a common factor of 3. So we'll pull a 3 out of everything. There's your 24x squared right there. If you were distributing, you get your negative 30 right there, and you get a 3 in the end. This 3 times that 3 would give that 9. Okay, so we want to set up our answer here, and one thing I'd like to point out is that this common factor that we pull out, you don't want to lose along the way. All right, let's set up a star here and see what we can do about breaking this apart here. Okay, 8 for the leading coefficient. Multiplying here gives 24. So you need numbers that multiply to give 24 and add to give the negative 10 that's down below there. And you might not need your calculator to do this, but if you want to see the factors of 24, you just type in this on your y equals line, go to your table, and in this case, I'm going to restart my table at 1 here. Okay, so 1 and 24, you're not going to get 10 out of those numbers, but 2 and 12, if you play with the signs, might work. And let's see, is there any other way to get 10? Maybe 4 and 6. Okay. Now the problem here is we have to have a positive. The only way to get a 24 multiplying is to do either positive times positive or negative times negative. In other words, these signs have to be the same. And this line won't work here if you use the same signs. You'd have to make, for instance, a 12 and a minus 2. But if you take these, 6 and 4, you're going to be in better shape here because you can use both of them negative, and they add up to negative 10, and they multiply to give 24. So you got to be on your watch. You got to watch out because sometimes there's a pair that looks tempting that's wrong. Okay, so we'll simplify this to 4 over negative 3. And this side to 2x, 2 over negative 1. And you fill in with the x here. And then double check here by multiplying. This gives 8x squared times 3 would be 24. So that checked out just fine there. The last times last is 3. 3 times the 3 on the outside would be 9. And the only thing left to check is this negative 30 in the middle. Negative 6x minus 4x is negative 10x. Then you triple it because of the 3 on the outside, and you get the right value there. Okay, I'll end here on this video by checking this one numerically. So I'll take a random number and store it as x. Hit the store key that's on the left-hand side of your calculator and type the original numbers or expression, 24x squared minus 30x plus 9. And that gives that value of 8.4 and change. And then I'll type the one at the bottom, 3 times 4x minus 3 and 2x minus 1. And this gives the same numerical answer, so we're in business. And that concludes all the way through problem 22 on your review.